All right, and we're back to the, I guess, iPad doodling world, and we again jumped forward another about 10 or so years, so we're up to 1965, so super old still, but still kind of fun. So if I go back to my list of things that I saw before, we're living about here now. So if we go back to this world, we'll see some nice little pictures emerging. So we have these linear feedback shift registers, approaches to generating some of these random numbers. These ones are kind of fun. They're also somewhat interesting to implement just because we get to play around with some shifts and things like that. So we have kind of a nice and very fast way to generate the next couple of things. What's going to happen is we're going to take our initial seed value. We're going to think about that thing stored in a binary format. So if I take the number 143, which I may or may not have mentioned to you, is Mr. Rogers' way of saying I love you. So I having one letter, love being 4, and you having 3, you get this number 143. Which written in binary comes up with those 8 little bits of 1, 0, 0, 0, 1, 1, 1, 1. We're going to also introduce what are referred to as some tap points. So those are going to be some things that we're going to touch to essentially grab the values from, and they're going to then be used to generate the next number. There's going to be a shift that happens, and then there's going to be an appending on the backside. Hence the name that emerges there. Here, I'm going to grab my tap points as 0, 2, and 5. So you can see 0, 2, and 5 in my little list that I have over there. What I'm going to do with the values that exist at those tap points is that I'm going to XOR all of them together. So think about taking that 1 and 0. When you XOR 1 and 0, so 1 XOR 0, that kicks out a 1. And then after that, I'm going to XOR it with the value that comes from the index 5, which is another 1. And we take 1 and you XOR it with a 1, because those symbols are the same, it's going to kick out a 0. So that's this visualization that's happening there. So you have 1 XOR 0, which is kicking out a 1. The 1 comes down from over there. So 1 XOR 1 is going to ultimately kick out a 0. That little 0 bit is then going to be put at the backside, kind of as the caboose on the little thing that we had before, and everything else is going to shift. While shifting, this one's going to drop off. So the kind of engine of that disappears. Everything else shifts over, and then you get a new caboose. And then you rinse and repeat that process over and over and over again, and you get some nice, cool little random numbers. How you choose to seed this is then up to you. What you choose to be your actual tap points is up to you. You have to have at least 2 things, otherwise it's not a very interesting thing. But you can have many tap points, you can have much longer seeds. There's lots of other things that you can do with this as well. So the linear feedback process, again, it's kind of old, but it's then been modified and reformed into lots and lots of other things. So this Mersenne twister, which is kind of the background for kind of how random numbers are generated in a lot of other programming languages. So like things like R and Python, I believe, all have that in the background. Those are basically modifications of these linear feedback shift registries. So they're old, but they're also kind of fun to look into as well. So if I keep that chain going for at least a couple before I got lazy and just jumped into the code, you can see a little bit of the swirling that's going to occur. So if I take that initial term, so 143, so I grab the tap points, so the 1, 0, and 1. So I underlined those in the green. You XOR all of those together, it gives you that bit of 0. So then you shift everything over, add the 0 to the end. So that was the visual that we had right here. So then you repeat that process. So formally, I'm living at a random number of 30 now, because I lost my really big number. So I no longer have the 128 because that fell off the front. So now I have what? Triple zeros, quad ones, and then a 0 at the end. You grab those things that live at the tap points, so those underlined because I'm tapping at 0, 2, and 5. You XOR those together. So formally, you would take the first 2 zeros, XOR them together, which is a 0, and then you XOR that with a 1, which will create that next bit as a 1. So everything in the old chain scoots over, so that leading 0 is going to fall off, and then you put a 1 on the backside. So now you have 2 zeros, still the 4 ones, the 0 from last time, and then that new 1 on the backside. You grab those things that live at the corresponding tap points. So 0, 1, 1, XOR all of those together, gives you the new bit of a 0. So you have 0 XOR 1, which is a 1, 1 XOR 1, which is a 0, because they're the same. Everything gets shifted to the left, and then we're going to add on that 1 on the backside. Keep that process going and hope to see some random swirling things occur. As with the other ones, because I'm only having outputs that are of length 8, because I've fixed it to have length 8, you can make that variable. So whatever you fix it at, you're still going to have repetition at some point. Because you only have 256 possible outputs, or 2 to the little n number of outputs, depending on how many bits you feel like working with, you're naturally going to have a collision or have some type of repetition emerge eventually. When that happens, because it's deterministic, you're going to start repeating. So you'll have that little cycle emerge, and obviously it's bad news from the random number side of things. I'm going to jump to the code, and then I'll actually jump back to the notes just because I did make use of some of the little shifting-y kind of things. So if you're, not super comfortable with some of that, or it's been maybe a little while since you worked with some of that, I do have a little bit more of kind of what's going on in the notes. So depending on how much I choose to talk over the code versus come back to here, we'll see how that kind of shift, add the new thing, and then restart all goes. So I'm going to hop into the code just so we can kind of see the chain of stuff emerge. And let me get that going. Probably need to restart the page because I had to the last couple of times. This has been sitting here idle for too long. I'm going to hit run to make sure everything is set. Cool. Okay, so we are feeding into this thing that number 143. This one has a very short cycle length, which I did intentionally just because I wanted it to terminate relatively quickly. So as before I have my seed, I'm going to have how many bits I feel like working with. So you can, technically change that 8 up to a 16 or whatever you feel like working with, and it'll just increase the length of those. Even though that number 143 only needs those 8 bits, you could pad it with a bunch of zeros if you wanted to as well. So you basically don't have to have your seed value have a leading 1. So I am hand coding the number of bits here as being an 8. I identified my tap points of 0, 2, and 5. And then if I hit go on this, it should start doing its thing. What's kind of pretty, right? I know I just kind of think it's interesting is to visually see this shifting actually occur. It's also interesting to see the very nice patterns that emerge in the binary, not so obvious, obviously, in the regular numbers over there. So it's one of those, as a human, you see these numbers over on the right, and you're like, oh, that kind of looks like a nice little random chain. But then if you actually look at the binary side of things, you can see this block of 4 ones shifting off to the left and then slowly falling off as other things get added back on. And then towards the bottom, you can start to see that block of 4 ones slowly start to get added back into the system. At that point in time, you're back to 143, and you obviously have a cycle of length 15 that's going to be formed. I got a couple other examples over here that I can turn on just to see things that might have slightly longer cycle lengths. So 142, so if I have that with tap points of 0 and 5, that one I actually claim is going to have a cycle of 217. So let's see if that's true or not. And it appears that it is. So we end up getting back to where we started, so that number of 142. As I mentioned before, it's kind of cute. If you go to the top and then just kind of scroll, you can very visually see this shift process emerge. So if you kind of like animate this thing, you can see this kind of almost like twist that's actually occurring. Again, some spoiler, the Mersenne twister actually does make use of some of these little feedback shifts and things like that. So there's some naming conventions that do go on in those as well. If I go back and turn these things off, so the original one that I had, so that it's set up for later use, that one only has a cycle of length 15, which is obviously super short. Because my outputs are only going to be one, of the numbers up to 256, we're going to have that cycle emerge. Here we're seeing a cycle of 15, which is super short, but it is what it is. Okay, so down in the code, just to kind of showcase a little bit of what's happening, the way that everything is going to be stored. So when you think about drawing out this picture, you're going to have it, from 0 up to 7. Though if you were to take that number 143 and write it in binary, it's going to be the other way around. So if you, would see that, it would be all flipped around because you'd have, that least significant bit hanging out way over on the other side. So it'd be flipped around. So it's kind of funky in terms of how you want to go about it. So if you want to think about your tap points as being 0, 2, and 5, there's a little bit of shifting that has to occur. So that's actually what's happening down below, is that I'm going to take in my original taps and then I'm going to flip them around so that they're in what I like to think about as, the right binary version of it. And then after that, we're going to make use of the easy shifting abilities within, normal programming languages to actually do this, shift the thing, add the thing, and repeat it. So I'm going to have my original seed that's going to come in. If I take that and then hit it with an AND with 8 ones, it's going to ensure that I actually have 8 bits actually in play, because it would kill off any of the other things. So that's all that process is doing, is just ensuring that I actually have, the 8 bits or the N bits that I have in play. To create that chain of, 8 bits or 8 ones, you can fairly easily do that. You just basically go over to a 9, so 2 to the 9th minus 1 will create that process, which is what this little R object is doing. Then I'm going to take this LFSR, so linear feedback shift registry. I'm going to initialize that as my start state. As before, I'll have a counter, which is going to keep track of how many things I have. I'm going to start storing all of these things in a big list called scene. And then as long as I've not seen the output before, I'm going to keep on marching. So I'm going to add that thing to the list of scene. I have a little bit of printing that's going to showcase what's happening here, so what's done before. And then we're going to do our arithmetic. So my tap bits, what that's going to do is it's going to grab those little entries. So the thing that lives at 0, 2, and 5. I'm storing those into a list, and then I XOR all of them together to actually generate my, final bit that's going to be added to the end. So the easy way to do that is to take that thing, shift it, tap units over, and then AND it with a 1 to extract out what that number happens to be, and then take all those numbers and then XOR them together. So that's what's happening in there, is that there's a shift, tap units, you AND it with the 1 to extract out the actual thing that you care, and then XOR all of those things back together at the end. And then at the very end of this is then I have to take that chain, basically remove the engine from it, and then add in the new caboose. So there's a shift over, add in the new caboose. So that's what's happening in this line of code. So you're going to take your current thing, you're going to then hit it with an AND, but you're going to hitting it with an AND with a chain of 7 ones. So when you AND those together, then that engine is going to turn into a 0. It's going to fall off, basically. So then you're going to take that chain and you're going to shift it over 1 unit. That opens up that last cell as being a 0. So then you're going to XOR that thing with your new little bit that's going to emerge on the backside. So it's that little bit of dancing and shifting and things that are going to occur. So that's all happening in that little line of code. You got to make sure, again, it's being stored, it's written like a normal binary, so it's flipped around a little bit. So make sure your arrows are all going the correct way. So a couple printouts, obviously, make sure things are what they are supposed to. Increase my counter, do a couple extra little print statements as we had before. So I'm not really changing anything in each of these codes. It's just kind of how I generate the next thing. That modifies a little bit, and then you keep that process, rinse, repeat, do a bunch of crazy things, go from there. Boom, whole bunch of random numbers. You will play around with this a little bit more on your next activity. So I'm going to have you do a few of these by hand just because they're kind of cute and interesting to do. And then we'll be looking at kind of this natural question of like, how random are these things? Are they actually creating a good amount of mixing, or are they seemingly somewhat stagnant in that they're not swirling around quite enough? So we'll touch back on that a little bit more in, 2 or 3 more videos, I guess, once I get to these ones that are called, things, but with the word continue at the end. We'll start kind of chatting about how do we know if these things look actually somewhat random. All right, so I'm going to jump back to the notes. I'm probably not going to talk over the things that I just kind of mentioned there. If you're curious of kind of the bit shifting aspects of things, you can take a peek at those in the notes. They were this kind of last little page. It may or may not be actually showing it, but anyway, it was that last page. Nope, it didn't yet. I want to go to the Safari side of things and share that. Go share. Okay, well, whatever. It's not wanting me to share. So it is on that like last little page. If you go into the notes, you'll see some of those things emerge. So you can take a peek at them. But currently, Zoom is being bad about wanting to shift back to my iPad. But if you're not super happy or not super comfortable working with some of the shiftings of things, take a peek at that. I tried to walk through one of the little examples, but if you run enough of the code examples, you can kind of make sure things are being shifted where they are supposed to. All right. See you in 30 seconds. Pending my iPad allows me to swap it back.